Hi, welcome back. So now we're going to take a look at a language that is not regular. All right, so this is up here. This is a regular language. This is a regular language because you can have any number of A's followed by any number of B's, but there's no relationship between the A's and the B's. This right here is not regular because you have to have this any number of A's, but then you have to have the same number of B's. So you need to keep track of how many A's you have and then get that same number of B's. And how can you do that if you have a cycle on your A's and you're trying to count the number of A's and then count the number of B's and match that? It's not possible to do with a DFA. But you do a proof by contradiction where you say, I assume that I do have a DFA, and my DFA has a finite number of states. So the 5 tuple of the DFA, these are my states. This is my alphabet, my transition function, my initial state, and my final state. So now I take a look at my transition function for A. So A to the I, so if you take a look here, what this is saying that I'm going to go from Q0 with A n number of times, and I'm going to end up in Q. But I'm also going to go to Q0 with A with m number of times and also end up in Q. So it's saying that because I can have any number of A's, I'm going to continue to read A's, and I'm always going to end up with in this state Q, whether I have 1A, 10 A's, or 100 A's, I'm going to continue to consume these A's and end up in state Q. And it's not always going to be the same every time. So it's not like n is the same number all the time. So it's saying here that since I'm going to end up in Q, right? So I'm going to get all of my A's and I'm going to end up in Q. Then after I get all of my A's and I end up in Q, I'm going to have n number of B's and I end up in the final or accepting state. But what if I have m number of A's and I end up in Q? Then n and m aren't going to match. So then you can assume, and that's what this is, this is a complicated way of saying that what if m and n, so yes, they could match. It's a possibility that you could have the same number of A's and the same number of n's, but we're saying here that if it works for one string, then and it does not have this property, then it cannot be regular. So I'm saying, okay, I could have n number of A's and then have n number of B's and end up in a final state. But I also could have a number of I also could have less A's or more A's and not have the same number of B's. So basically, the thing about this whole thing is that a DFA does not have the ability to count and keep track of how many A's and then match it and get the same number. So if you see anywhere where, I'm not going to have you guys in this class, I'm not going to have you write out the very complicated theorem for the pumping lemma at all. I might have you identify whether or not a language is regular. So if you can look at it and you can draw your DFA, you can identify right away that it's a regular language. If you're struggling with how to draw the DFA, then you can conclude that it's not regular by the idea that you can see in the language definition that you can't keep track, like you can't count. I can't count the number of A's and then get the same number of B's. So here is an example where picking the m, if I pick m is 2, the size of xy must be less than or equal to m. So I have to do this in the first 2 symbols of my string. My string that I selected is A, B, B. So A is pumped, my Y is going to be A, it's going to be pumped, I pump my A, and if I can pump my A as many times as I want, but I can't pump my B the same number of times because there's no way for me to keep track of the same number of A's and B's. So here's another language that is not regular. So how can you show that this is not regular? Well, first you can look at it and identify that I'm going to make a string in my language, which is W, and then I'm going to have to match that string only in the reverse, right? So how am I going to know? So if I have this, if my alphabet is AB, say my alphabet is AB, and I have this string A, B, A. So this is W right here. So W reverse is going to have to be A, B, A, A. That would be W reverse. And then if I consume this string, then I'm going to be able to go to a final or accepting state, right? So how can I take this part of my string in a regular language in a DFA and keep track of all the symbols so that I can match them in the reverse on the second half of the string? All right, so I put the explanation here, but now if you select an M, you select any M, all right, so then you select some number M, you select a string in the first half and pump it. So if you selected M equals 3, I select some string in the first half of my language here. And so I can select that whole string there in the first half of my language. And if I pump anything in this string, then it will not be in the language, right? Because there's no way for me to pump this and then this side is not going to know what's pumped and it's not going to be able to match it. If you select a string in the second half and pumped it, the new string will not be in the language. And a new string with an odd length also cannot be in the language. So this is not a regular language. And you only need to come up with one example to prove that the language is not regular. So let me repeat. You could come up with if you have a description of a language and you can create a DFA for that description of that language is regular. Okay? If you cannot create a DFA, like you're trying to create the DFA, but it's not very clear how to create the DFA, you can prove that it's not regular by showing how you can pump something in it and the resulting language after the pump is not in the language, then it's not regular. But the even better way is the memory part. You can't remember. You can't remember the first string so that you can create the reverse of that string after. In A to the N, B to the N, you can't count the number of A's and then have the same number of B's. So here's one more. Is this a regular language? If you have the number of A's are less than the number of B's. This is not going to be a regular language because how can you make sure that the number of A's are less than the number of B's? If you pump your A's, then you're going to, this is infinite. You can have an infinite number of A's and an infinite number of B's. So if you pump your A's, you're not going to be able to keep the string, the resulting string is not going to be in the language. So if you select an M, so then you're going to say, okay, I select the M, so the string that I'm going to pick is going to be A to the M, B to the M plus 1. So that's going to be any string in my language. If M is 1, my string would be A, B, B. If M is 2, my string would be A, B, B, B. So because the size of XY must be less than or equal to M, so if M is 1, then I must choose an A. If M is 2, I must choose an A. So if I pump the A, then the string will not be in the language, and therefore I conclude that the string is not regular. And I just want to let you know that I'm not going to ask you to write, for this course, I'm not going to ask you to write detailed proofs to prove that a string is not regular. So just to review the strings, this is a regular language. An infinite regular language, you must have a cycle in your graph. So if you have a regular language, there's going to be a cycle. And that cycle can be pumped. And when you pump that cycle, you will produce strings that are part of that language. And then we did 3 examples that are not regular languages because you can find strings that can be pumped and therefore they do not produce strings that are part of the language. If you pump your A's, then you're not going to have the same number of A's and B's. If you pump your B's, you're not going to have the same number of A's and B's. In this case, if you pump your A's, you're going to end up with more A's than B's. And in this case, if you pump any string on this side, it's not going to match the other side. Or if you pump any string on this side, any subset, any substring, any symbol on this side, it's not going to match the other side. So the bottom line is that regular languages cannot count things, cannot keep track of things. They only have the memory of the state that they are currently in. A DFA has no memory. It only can keep track of the current state that it's in.